Hello students, welcome to chemistry. We've already talked about continuous double indicator titration. We said for double indicator titration, one of the samples is made up of a mixture of two different substances. And we want to calculate the amount of each of those two substances present in the mixture. In the continuous titration, we learned that we will first add few drops of the phenolphthalein indicator, start our titration. When the color changes, we don't stop. We add few drops of the methyl orange, then continue the titration. Hence the name continuous double indicator titration. In this video, we'll be looking at discontinuous double indicator titration. This one is quite different from the continuous double indicator titration. Discontinuous titration is also another type of the double indicator titration. So we also call it discontinuous double indicator titration. Now, this one is just like the continuous one because here we still have one substance made up of a mixture of two different substances. And we want to calculate the mass or the amount of each of the substances present over there. But the difference is over here, we won't continue the titration. In fact, we are going to perform two separate titrations. The first one with phenolphthalein indicator. When we are done, we are going to discard the solution, pipette another portion of the solution B, and this time we are going to add methyl orange. That is the discontinuous. So we are not continuing with the titration with the phenolphthalein. No, we are going to perform a different one with the methyl orange. Hence the name discontinuous. Let's try and delve into it and see how it is performed. So after adding or after pouring our acid into our burette, we have to adjust it to the 0th mark. And once again, we have to take off our funnel. Because as you can see, there are some few drops of the acid over here. So if the funnel is inside whilst I adjust, I might get to the 0th mark, but that small amount will release and add to the solution, increasing its volume. Remember, this is volumetric analysis. We are measuring volumes, and it's a form of quantitative analysis. So quantity is priority over here. So we adjust until the bottom of the meniscus sits on the 0th mark. Now that 0 is going to be our initial volume of acid. Then we will pipette 25 centimeters cube of solution B, which as we know is a mixture of two substances, sodium carbonate and sodium hydrogen carbonate. Then we adjust. So the bottom of the meniscus is sitting on the mark. There we go. Then we transfer it into our conical flask. Then we tap the base of the conical flask once or twice with the tip of the pipette. Then we add our 2 to 3 drops of our phenolphthalein indicator. 1, 2, 3. I'm using 3 drops. Then we have our purple color. I'll be adding the acid until we get to the appearance of a colorless solution over here. Now, you can see a colorless solution. Then you come and read the volume. The volume is at 5.0 centimeters cube. That's it for the first titration. So what I'll do is I'll discard this solution. Then we are going to perform another titration again. But this time, we are going to use methyl orange as our indicator. Now don't forget to put down the value you had for the phenolphthalein indicator. Then we add 2 to 3 drops of our methyl orange indicator. 1, 2, 3. 2 or 3 drops of our indicator is enough for us to see a clear color change during the end point. Don't add 4 or 5 or more drops, please. 2, at most 3. So, this is a new titration. Huh? This time we are using methyl orange as our indicator. And now are you seeing the effervescence? So we have our color change. And we have 26.0. Chances are, since this is our first titration, we might have overshot our endpoint. So in the second titration, when the mark is on the 0 on our burette, and we start adding the acid, we can release up to 4 centimeters cube, swirl the solution, and go dropwise till we catch the endpoint for the phenolphthalein titration. You will discard the solution, pipette another 25 centimeters cube again. This time add methyl orange indicator. Now we have 26.0. So we can release from 0 to 20. Then we will swirl our solution, then go dropwise. We are going to catch the actual end point. Let's see how that one too is done in our second titration. Then we add our 2 to 3 drops of our phenolphthalein indicator. 1, 2, 3. Then we perform our titration till the color changes to colorless. Now, we are going to release from 0 to 4 because last time it changed at 5. Then we add dropwise. The color looks colorless, but there are still some traces of purple inside, so you want to get rid of those traces. Colorless. And the volume is at 4.80 centimeters cube. We record that volume, then we will discard our solution. So we release from the 4.8 till we get to somewhere around 20. We will swirl and continue with our titration. By this time, we will add the acid dropwise so that we can catch our endpoint. Then we take our time. We want to catch our actual endpoint. Just one drop. So our endpoint is at 25.70. 25.7. Please zoom in for me. 25.80. Good. The top of the meniscus is on the 7/0th mark. And the bottom of the meniscus is on the 25.80th mark. So don't let us confuse ourselves. The top of the top of the meniscus is on the 25.70, but the bottom is on 25.80. And we read based on where the bottom of the meniscus is lying. So our endpoint falls at 25.80. Then we put that one down. Remember I told you, you will be marked based on what your teacher gets from his personal titration. Now, he's not supposed to disclose that value to you. But if you perform your titration very well, the right way, you are going to get within your teacher's values. And how do you perform it very well? The first titration I've told you is called the rough titration. It gives you a fair idea where the endpoint is hovering around. But in the second titration, don't get it wrong. If you get, say, 10.0 centimeters cubed for your first titration, in your second titration, just release the acid from 0 to maybe 8 or 7. Then, swell your solution. Dropwise, swell. Dropwise, swell. You will actually catch the endpoint. So this is how the discontinuous double indicator titration is performed. This is how the table for discontinuous double indicator titration should also look like. As usual, we prepare two tables, one for phenolphthalein and the other one for methyl orange. Now, we started our titration here. We did 6 different titrations. And the first one, we started with 0.00. We added methyl orange indicator, and we arrived at an endpoint of 5.00. Then, we started with the methyl orange titration. That one too, we started at 5.00, and we ended at 26.00. And the second titration, we started with 0.00, and we had our endpoint at 4.80. In the fourth titration, we started with 4.80 and ended at 25.80. The fifth and the sixth titrations were done off camera, and we realized these values. For the phenolphthalein titration, we had 4.90, and for the methyl orange titration, we started at 4.90, and we ended up at 25.90. The titer becomes the difference between the final and the initial values we had. So over here we have 5.00, 4.80, 4.90. Over there we have 21.00, another 21.00, then another 21.00. Wow. Wow. That's what we had for the 2 titrations. Now, to calculate the average titer, we need any 2 values from the table that are consistent. So you realize they are all consistent. So I'm going to choose the ones that are more consistent, 4.80 and 4.90. So 4.80 plus 4.90 all divided by 2. And I'm getting 4.85 centimeters cubed. You could also choose 4.90 and 5.00. That one too is consistent. And even though 4.80 and 5.00 are wider apart, they are still consistent. But it will be better to choose 2 values that are more consistent. So 5.00, 4.90, 4.80, 4.90. They are more consistent. So it will be better to choose them. In the second titration, realize all the values are the same. So 21.00 plus 21.00 all over 2, and that gives us 21.00 centimeters cube. So these are the average titers for the individual titrations. The 4.85 centimeters cube is for the phenolphthalein titration. Then the 21.00 centimeters cube is for the methyl orange titration. But how are we going to use these values to calculate the concentration of sodium carbonate in the mixture and of sodium bicarbonate in the mixture? Our next video will address that issue. Thank you.